Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 5 from the February-March 2022 A-level paper from Cambridge 9709. This is the pure mathematics paper, and this is a question here. First of all, it seems related to completing the square for this quadratic, although it's not exactly as it might seem. So you've got to be very careful not to lose a mark here, because the question says express this expression in this form. Now, if you didn't look at it carefully, you might think it's like a general type of, where you got to end up with p times x minus a squared plus q, something like this, right? But no, here you have 2 as a factor of the whole thing, and then inside it's completing the square. So it's normally you would multiply the 2 with this bracket and the 2 with this number and have it in this form, but it's not quite the same. So if you're going to do this without reading the question carefully, you might end up giving it in a form that will lose you a mark, because it's not the form that they require for this part of the question. So if you want to express 2x squared minus 8x plus 14 in this form, then the sensible thing would be for you to do would be to take out 2 as a factor of all the 3 terms, because we want to end up with that 2 outside all the 3 terms, the whole thing anyway, right? So I'm going to take out 2 as a factor. I'm going to have inside x squared minus 8x divided by 2 is minus 4x, and 14 divided by 2 is plus 7. So I haven't started to complete the square yet. All right, we've just taken out the 2 from all of the terms. All right, now we can start completing the square with what's inside here. So I'll have 2 times, and then I'm going to have my outer bracket, and then the inner bracket here you have x minus, this is going to be a squared bracket. Now what goes inside here? Of course the x goes inside here. The minus sign goes inside here because there's a minus between the x squared and the x term. And then you take the coefficient of x and write a half of it in this space over here. So this is now x minus 2 all squared. If you were to square this, you would get x squared, you get minus 4x, but then you get plus 4, which we don't want. Okay, so I'm going to take away 4 from this. Now these two are basically the same. This is the same as this. If I was to expand this, I would get x squared minus 4x, because you get x squared minus 4x plus 4, and then minus 4. They will cancel out, leaving you with this. All right, so they're the same, but now you see at the end of that I have a plus 7, so I have to write plus 7 at the end of this as well. Now I can simplify that, so it gives me 2. I don't expand the brackets, I just leave the 2 outside because that's the form they want, and that's going to become plus 3. So this is the form that they want. If you were to end up writing 2 times x minus 2 squared plus 6, this is actually a correct form in terms of this is how you would complete the square, and that's how you would finish it off if you were to do it normally. However, they want it in this form, so don't go on to do this, otherwise you will definitely lose a mark, because they want it in this form. Follow the instructions that they have asked you to follow. Okay, so there's part A done, right? Not too difficult, but just take care of that little point there. Now for part B, it says the functions f and g are defined by f of x equals x squared, where x has a domain of all real numbers, and g of x equals 2x squared minus 8x plus 14, which is our expression that we had earlier, that we just dealt with now. And again, x is an element of all real numbers. There's no restriction on the domain for either of those. It says describe fully a sequence of transformations that maps a graph of y equals f of x onto the graph of y equals g of x, making clear the order in which the transformations are applied. So now when you have a quadratic, and you want to think of it in terms of transformations, then having it written in the form where you have completed the square, okay, is going to be very helpful for you. So if we rewrite g of x in the form that we have made it, so you can say g of x is equal to 2 times, in brackets, x minus 2 squared plus 3. We could also write it for the purposes of this, in transformations, you could also think of it as 2 times x minus 2 squared plus 6. Both of those are forms which we can use transformations to show how x squared became these. So x squared becomes, let's take two different scenarios. Let's start with x squared becomes the way they asked us to write it: 2 times x minus 2 squared plus 3 in brackets. Supposing they told us to, we want to show how x squared becomes this, okay? So f of x becomes g of x. F of x becomes g of x. What happens to f of x? Well, the first thing that happens to f of x, the original function, okay, I'm going to show method one. Method one, okay. So the first thing happens is, the first transformation that takes place is that the x has been replaced by x minus 2. Remember, when we're dealing with transformations, we have to go in a particular order to make sure that we don't make any mistakes. Sometimes the order matters, sometimes it doesn't matter. Okay, but you have to, it's always best to follow the order. So the general rule is to first deal with the inner transformations, what happens inside the bracket. Okay, so you deal with what's inside first. So I'm dealing with what's happening inside. The x squared became x minus 2 squared, right? So those always affect the x coordinates. They always affect the x coordinates, and they always like act, you can say, opposite. So this actually is representing a translation, all right? A translation, and the translation is given, is in the x direction, but you're going to go to the right. X minus 2 inside the function means 2 to the right. So translation of 2, 0. That's a vector that tells you. So you move the graph of y equals x squared will move 2 spaces to the right. Okay, under this transformation, this first part. And then we deal with the outer function, the outer transformations, the outer changes. Okay, and they affect the y coordinate, what's outside the function. They affect the y coordinates, and they are kind of act normal, you could say. So if we look at this, and for the x coordinates, opposite, we do the opposite of BIDMAS. All right. In this case, there's only one transformation, which is the subtraction. Okay. But if there was a multiplication as well, we would do the subtraction before the multiplication. So if it was 3x minus 2 inside, we would then deal with the true translation first, and then the stretch. Okay. So in this case, there's only one inside. But with the outer, we deal in the order of BIDMAS. Now, if we're dealing with the expression in the way that we were told to express it in this way, then we have BIDMAS would mean we deal with what's inside the bracket first. So I would do, okay, the part which it says fx minus 2 plus 3. Now we're going to be dealing with this part, which is, we dealt with that part just in the first part. Now we're going to deal with this part here. Now what does that represent? That represents another translation. However, this is in the y direction because it's outside the brackets, in the outer part of the function. It's not inside this bracket. It's not inside this bracket here. Okay, when it's inside this bracket here, then it is considered affecting the x coordinate. So this is a translation. Okay, it's considered outside of the function. So it's going to be affecting the y coordinates and acting normal. So plus 3 means 3 up. So 0, 3. Now we could, if we wanted to, combine these two into one translation as 2, 3. If you write it this and then this, or you write that, it's exactly the same thing. No problem whatsoever. Okay? Exactly the same thing. And then we have the next transformation, which is basically dealing with the fact that the whole thing is multiplied by 2 now. So it's like 2 times fx minus 2 plus 3 in brackets. So that is basically, now we're dealing with this part 2 times. Okay, now this is when you're multiplying, it's dealing with, it's a stretch. If the whole function, if it's outside the function, if it's multiplying the outer function, then it's got something to do with a vertical stretch. So this is a vertical stretch, and the scale factor is equal to 2. Right, so there's where you multiply all the y coordinates by 2 and the x coordinates stay the same. And those are the transformations that we can have. We could write this as 2, 3, and then the vertical stretch of factor 2. That's fine. Or we could write them as separate translations and then the vertical stretch of factor 2. It's exactly the same thing. It doesn't make any difference. Both of those would be fine if I did it like this, or I did it like as one and then the other. That's fine. So that's the first method, as if we were looking at this in this form. All right, there's another method we could use, and it would be perfectly fine. And that would be if we think about x squared becoming 2 times x minus 2 in bracket squared plus 6. It's like when you expand that. If we were, this should give us exactly the same result, of where the function should end up. And we're going to test a point to make sure, just to show that it's going to give you the same thing anyway. So what happens here, in this case, what's happening first is, my pen's got messed up. What's happening first is, just fix this, is a, okay, so we're going to deal with the inner function first again, right? So we deal with what's inside the bracket. So the first thing is the same as before, exactly. We're dealing with fx minus 2. The x has been replaced by x minus 2, okay, which is, again, a translation, and it's inside the function, so it acts opposite. So it says x minus 2, you go 2 to the right, okay? Now, the second thing we would deal with normally now, in this case, we would take, if it's 2 times x minus 2 squared plus 6, we would now deal with the outer function, and we would start with BIDMAS. So we'd start with multiplication. So we'll deal with this vertical stretch. So this we're going to deal with 2 times fx minus 2, which is a vertical stretch. And the scale factor is equal to 2. Okay, excuse my writing. And then finally, the third thing that we'll deal with is the 2fx minus 2. We're going to have to then, this is plus 6. So this will be a translation. Now this is going to be in the y direction because it's outside the function, a translation of 0 horizontally and 6 up. So it'll be 0, 6. Okay, that will be the translation. So we've dealt with here, first of all, we dealt with the inside the function x minus 2. Second, we dealt with the 2 times fx plus minus 2. And then we dealt with the translation 6 units upwards. Okay, now what I'm going to do is I'm just going to show you how, whichever way we use, we should end up with the same situation. So supposing I take, for example, say the any point like on this curve, right? So for example, if I know that let's choose y equals x squared. Let's choose any point on y equals x squared. For example, let's choose a point 2, 4. 2, 4 is when y is equal to square root of x. What happens to 2, 4? All right, under this first situation. So first you translate 2 to the right and then 3 up. So 2 to the right, that means you affect the x coordinate. So it's going to become 4, and 3 up, it's going to become 7. And then that's after transformation 1. It's like 1 and 2 together, you can say. And then we can have the third transformation, which is where we multiply the whole function by 2. So that means that y coordinates are changed, the x coordinates are unchanged. So the x coordinate stays as 4, and the y coordinate becomes 14. So that's where that point will end up under this transformation. Let's see what happens. It should give us the same thing. Let's see if we do it in this way. We'll start with 2, 4. That's a point on y equals x squared. Y equals x squared. Now, in this case, the first thing we do is we translate 2 to the right. So that means the x coordinate becomes 4. So you end up with 4, 4 after the first thing. The second thing we do is we have a scale factor, a vertical stretch of factor 2. So we multiply this y coordinate by 2. We end up with 4 and 8. And the third thing we do is we translate 6 unit upwards. So the y coordinate, you add 6 to it. So you end up with 4, and 8 plus 6 is 14. As you can see, we end up in the same place. So whichever way you do it is fine. This way is following in the way that they have shown us, or the way they have asked us to express the expression. This is in a way where we have just multiplied everything by 2, expanded the bracket, and then done it. It will give you the same thing, of course, and I think either way would be fine, as it's mentioned, I think, in the mark scheme. So that's perfectly fine either way you do it. I'm just showing you how it all fits in together. Hopefully that helps you understand about the order of operations and stuff. So yeah, so that's basically the answer to this question here. Question number 5 from the February-March 2022 paper. And other questions from this particular paper, if you click on the playlist that will appear at the end of the video in this area, it will take you to the playlist for this paper. Other questions dealing with transformations of graphs from P1 of Cambridge will be found in the playlist over here. I'll also add a playlist for my EdExcel collection of transformations, as this is a new topic, okay, since 2020 in Cambridge. So there'll be a lot more examples of it in this playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.